at Bawashiri Electric once more. Today we're gonna look at slip ring motor resistance starter. Slip ring motors are used in machines such as cranes, lifts, elevators in buildings, and so on. And we are going to look at resistance starter, say for example resistance box. So you are going to see the logic how to do the connection, power line and the control line of slip ring motors. So let's go. Here my power supply as usual. I'm going to have line 1, line 2 with the neutral. Just like that, that is our power source. Then we are now going to have our components. I'm going to have here a power circuit breaker, I'm going to have a contactor, I'm going to have an overload, then I'm going to have the motor itself, slip ring motor. You can see how it has two coils. It has the armature winding and the rotor winding, where the armature winding is connected to power, while the rotor winding is connected to resistance, external resistance. So I'm going to have here my 3 resistance blocks. The first one, the second one, and the third one. So that is how we are going to deal with that one. So we do the wiring. But now for space, let me design it in a different way. This motor, actually we can rotate it. Like that, so that we can get a clear view. So we are also going to have other 3 sets of contactors. Where are they? They are here. We are going to have this contactor, we are going to have this contactor, we are going to have this contactor. So these contactors, they help us now to eliminate the resistance blocks in our circuits as the motor is starting. Now call this one our MCCB. We call this one KM1, this one KM2, this one KM3, this one KM4. So there are 4 contactors. This one overload, thermal overload, call it TH. Then this one motor M. Then this one is resistance 1, R1, resistance 2, R2, and this one resistance 3, R3. Now when we do a connection, get here our cables from the power to the circuit breaker to the first contactor KM1, then to the overload, then from there straight away to the motor. Now this way KLM, that is the rotor winding, the one connected to resistance. Shall we have that one to resistance 1, then at the end of resistance 3 we shall have a short. That means when a motor starts, in this case, it's going to start at full resistance. Then we're now going to have this one. Yeah, that is it. So now up these contactors we do a shorting. When you short this contactor, it means you have eliminated resistance 3 from the circuit. When you short this one, it means you have eliminated the resistance 2 and 3 from the circuit. And when you short this one, it means you have eliminated all the resistance from the circuit. Then there the motor is going to run at no resistance. So we are going to design the control. That one is done automatically. We are going to design a control in that the motor starts with full resistance. That means all these contactors must be open. Then it goes on cutting off one resistance block by one. So let's design the control circuit and we see. We're going to have our control breaker here. Then we are going to have our overload contact. Need a thumb overload contact, normally closed. Then we are going to have a stop push button. Then we have a start push button. So immediately when you press the power on, we are going to start by powering the main contactor, and that is KM1. We get our live from the nearest line through the stop. Then we power the nearest. We power KM1. In the same case, we are also going to power. We are going to have a timer here, and I'm going to call that one 3-1. Remember, our motor has to start in full resistance. So after a given time, so it's going to start KM1 as well as timer 1. Then before powering timer 1, KM1 has to self-hold itself from here, the start. That is KM1 contact. Then there it powers timer 1. Now we are going to have here power from the control breaker. And we are going to have through the normally open contacts, through the normally open of KM1, that's the main contactor. It is going to power timer 2 and KM2. I'm going to have here the coil for KM2 and timer 2. But KM2 is going to pass through the normally open of timer 1. Then we are also going to have at some instance KM3, that's contactor 3. and the same style is going also to have timer. So this is CAM3, I mean CAM2, this is timer 2. This is CAM3, contactor 3, and this is timer 3. So I'm going to have the last one, CAM4. CAM3 is going to pass through the normally open of timer 2, and CAM4 is going to pass through the normally open of timer. Now here I've done the vice versa. It is CAM4 which is supposed to start, then CAM3, then CAM2. So this one is, we have to start here with CAM4, then CAM3, then CAM2. It's the last one to go on. So this one is normally open of timer 2, and this one is normally open of timer 3. So the first one, this one, CAM4, this one has to pass through the normally closed of CAM2. We shall see why. So we get here this cable, this power, and we give the timer also. And this one has to pass through the normally open. Why is it? The normally open of this has to be the normally open of CAM4. And this one was CAM2. So we do the cabling like this, and it powers the timer also. Then we have also another set that has to pass through the normally open of CAM3. Do like this. And we give the timer also. No, but for this case here, I don't think if we need this timer for. I think it has no use. We have 3 timers. Now, this is CAM3. Now you look at this logic here. When we start here CAM2, I see, when we start here CAM2 is going to open here. And when CAM2 opens here, that means CAM4 is going to go off. And when CAM4 goes off, it's going also to switch off here CAM3. And also when CAM3 goes off, it's going to open here. So that means all our resistance contactors are going to go off. We have to remain with the CAM2, this one. It has to remain on as these ones go off. So we are going to self-hold this one. We are going to have here a self-holding, and it is going to be for CAM2. It's going to self-hold itself. Now when we analyze this one, Now here when you press a start, of course you shall have KM1, the main contactor, with the timer 1 starting. Timer 1 is going to power on KM4, which is this one, the last one, with the timer 2. Then when these components are on, they are going to power on KM3, this one with the timer 3. And remember, as each contactor is powered on, it eliminates the resistances. So after the KM3 components, they are going to power on KM2, which is this one. As KM2 is powered on, these two contactors with their timers, they can go off still because they have no need. But this one, KM1, is the one which is supposed to hold this KM2 to be on. That means as long as KM1 goes off, also all these components have to go off. Let's first do the neutral and we see. And the switches, this one is MCB, this one is thermal overload, TH, then this one is hour stop, and this one is hour start. And that is it. Now you are remaining with the simulation with prior to, and you see whether we are on the right path. Now if we do a simulation, but let's first do some modification here a bit. These ones we are going to be powering them here from their respective coils a bit like this. Yeah, so we make that change. Then now one more last modification, we are going to get somewhere here, we are going to put a normally closed line, a normally closed contactor of KM2. That is the last contactor to go off. Now I think we can do a simulation and we see, please, here this is our KM1 main contactor, time 1. Then we start with the KM4 to power on, which is this way. Then we go on to KM3, then we go on to KM2. When we do a play here, this is our power breaker on, this is our control breaker on. So when you press start button, let me first set the time for our timers. I'm going to put to something like 2 seconds. Then we play. So and power control, and we press a start. So you'll see that the motor will start running, but at full resistance. KM1 is completed. So KM4 cuts off this one after some time. Then now KM3 cuts off the whole of this one. Then lastly KM2. So now when the motor is running at no resistance here, KM2 is closed. All these ones, they go off, they have no use. As you see, all these components are now off. We have only the main contactor with the KM2 contactor, which is now acting as if the motor is running in a star connection. So when we operate an overload, the whole system goes off. Are we there? So we start and see. We start with the full resistance. Then it goes on cutting off resistance one by one, one block by one block, by the help of these contactors, as you can witness. Are we there? Then now when you press stop, the whole system goes off. So briefly, that is how we go about with connecting slip ring motors to external resistance. And external resistance, I told you, it can be a resistance box, and maybe there could be another way or another format of coming up with such a circuit. You have your own way. You can maybe make a video or make a comment in the comments below, or make a video also and post for us the link in the comments below so that you can see how things are done in a various way. Or if there is any concern anywhere on this circuit, please, you're free to comment. And don't forget to subscribe, please, and hit the notification button for future videos. Thanks for watching. See you when you see me in the next tutorial. And whoever feels like there is a circuit you would like me to develop that you have not come across yet, please can also comment in the comments below so that we can see how to deal with it.